All right, welcome back, everyone. Today we're going deep on a topic that's pretty heavy, to say the least. Nuclear weapons. We've got a ton of research here, historical data, in-depth articles, the whole nine yards. And I think our goal today is to try to help you navigate the core concepts, the history, the different types, the effects, and of course the debates that still rage on today about these incredibly powerful weapons. So, ready to dive in.
Absolutely. I think it's a topic that deserves all of our attention. And understanding just how powerful these weapons are and their potential impact, well, it's crucial for anyone trying to keep up with events around the world.
Couldn't agree more. So, let's start with something basic. What makes a nuclear weapon different from, say, I don't know, a conventional bomb?
Well, nuclear weapons get their power from nuclear reactions, fission, like in atomic bombs,
Hmm.
or a combination of fission and fusion, which is what powers hydrogen bombs. The key difference is really the amount of energy that's released from such a small amount of matter.
Oh,
It's
yeah.
been compared to like squeezing the power of the sun into a bomb.
Yeah, the research we've got uses that comparison to TNT to kind of illustrate that scale.
Yeah, and the numbers are pretty mind-boggling. The first fission bomb test, that released energy equal to about 20,000 tons of TNT. But the first hydrogen bomb, 10 million tons. We're talking a completely different level of destructive power.
Wow, yeah. The research mentions this Tsar Bomba, which already sounds terrifying just as a name. What is that?
Well, the Tsar Bomba was the biggest nuclear weapon ever detonated, 50 megatons. To put that in perspective, that was enough to completely destroy a city like New York, with effects reaching far beyond that.
That's a chilling thought. And it leads us to a pretty somber part of our dive here, the history of nuclear weapons and war. We all know that the U.S. used atomic bombs against Japan in World War II, specifically in the bombings of Hiroshima and Nagasaki. The sources describe these events as a really dark chapter in human history.
They were. The casualties were horrific. It's estimated that about 200,000 people were killed. And the debate about the ethics of using these weapons and their role in Japan's surrender, I mean, that continues to this day. It's a very complicated historical and moral question that's worth exploring further.
For sure. And while those are the only times nuclear weapons have been used in war, there have been over 2,000 tests conducted since then. It is somewhat reassuring that only a handful of nations actually possess them. Can you walk us through the current nuclear landscape? Like, what does it look like right now?
Sure. The countries that we know have detonated and have nuclear weapons are the United States, Russia, which inherited them from the Soviet Union, United Kingdom, France, China, India, Pakistan, and North Korea.
North Korea's nuclear program has been in the news a lot. What's their current status?
Well, there's some debate about how sophisticated their arsenal is, but they have conducted tests and they claim to possess nuclear weapons. And this, of course, raises a lot of concerns, both regionally and globally.
Are there any other nations that we should be aware of?
Well, Israel is widely believed to have nuclear weapons. Although they have this policy of deliberate ambiguity, they don't confirm or deny it. And then there's the case of South Africa. They're the only country to actually develop nuclear weapons and then completely dismantle them, which was driven by their changing political landscape and a desire to stop the spread of these weapons.
That's pretty remarkable considering just how powerful these weapons are. The sources also mention the Treaty on the Non-Proliferation of Nuclear Weapons. It seems like a pretty important international agreement. What are its goals and what challenges does it face?
So the treaty aims to prevent the spread of these weapons with the ultimate goal of global nuclear disarmament. But there are differing opinions on how effective it's been. Some people argue it's been essential in limiting the spread, while others say that the continued development and testing by certain nations, well, that proves it's not really working. It's a really complicated issue.
For sure. Now let's talk about the different types of nuclear weapons. The sources make a distinction between fission weapons, the classic atomic bombs, and then fusion weapons, the hydrogen bombs. Can you break down how fission weapons work?
Fission weapons rely on splitting the atom, specifically the nucleus of an atom. They use materials like enriched uranium or plutonium, and the goal is to create a supercritical mass, which means you pack enough of this material together to trigger a chain reaction of splitting atoms. This releases a massive amount of energy almost instantly.
The level of precision required for that is incredible. How do they make sure that chain reaction happens at the right moment?
There are two main ways to do it. The simpler one is the gun method, where conventional explosives are used to fire a subcritical mass of uranium into another, creating that supercritical mass and triggering the chain reaction. That's the method that was used in the little boy bomb, which was dropped on Hiroshima. The other method, which is more efficient and more sophisticated, is called implosion.
Can you explain how that works?
So imagine a sphere or a cylinder. of this fissile material, and it's surrounded by carefully placed explosives. When those explosives detonate, they create a shock wave, and that compresses the material inwards, forcing the atoms close enough to trigger the reaction. One of the biggest challenges is making sure that enough of the fuel is consumed before the weapon itself blows apart. The more efficient the design, the bigger the explosion.
So that brings us up to fusion weapons, the hydrogen bombs, which our research says can be hundreds of times more powerful than a fission bomb of the same size. What makes them so much more destructive?
Well, fusion weapons use fusion reactions, which is the same process that powers the sun. They fuse atoms together, which releases a lot more energy than splitting them. And they actually use a fission bomb as a trigger to create the extreme temperatures and pressure needed for fusion to occur.
So it's like a bomb within a bomb. The sources mention something called the Teller-Ulam design. What is that exactly?
It's the design behind all modern thermonuclear weapons. You have a fission primary stage and then a fusion secondary stage, all contained within a special radiation-reflecting casing. The radiation from that fission explosion that's used to compress and heat the fusion fuel, which then ignites in a massive explosion. And in some of the really big H-bombs, they had a third stage that uses depleted uranium. It's a byproduct of the enrichment process, but it's used to boost the yield even further.
Wow. So with all this talk about destructive power, is there a difference in fallout between fission and fusion weapons?
Well, fusion reactions themselves actually don't produce as much radioactive fallout, but H-bombs still rely on a fission trigger. And those really high-yield explosions, they can throw radioactive debris way up into the stratosphere, where it can travel really far and contaminate places far away from the blast site. So there's no such thing as a clean nuclear weapon, unfortunately. And it gets even more complicated when you consider some of the other types of nuclear weapons out there.
Yeah, the research mentioned some other types that were kind of, well, terrifying. Can you tell us about those?
Sure. So there are boosted fission weapons. They use a small amount of fusion to make the fission reaction more efficient. Then there's the salted bomb. It was designed to maximize long-lived radioactive contamination, essentially making a place uninhabitable for decades, maybe even centuries. Then you've got neutron bombs. They prioritize neutron radiation over explosive force. Those were designed for specific tactical uses, like taking out enemy tanks while minimizing collateral damage, although there are some serious ethical issues there.
Wow. You know, we've all heard about broken arrows. What are those exactly, and why are they so significant?
A broken arrow is an accident that happens with a nuclear weapon that doesn't increase the risk of war. Like it could be a weapon that was damaged or lost or an accidental detonation. And they're significant because they highlight just how risky it is to handle and transport these things.
And our data shows there have been more of these incidents than you might think.
Oh, yeah. Experts believe that there were something like 50 nuclear weapons lost just during the Cold War alone. And some of those were really close calls. It just shows the need for really strong safety protocols and constant vigilance in managing these arsenals.
That's a pretty sobering thought, especially considering the scale of destruction we're talking about here. Speaking of which, let's talk about how these weapons are delivered. Dropping them from planes like in World War II. That seems pretty old-fashioned now.
Oh, for sure. Technology has come a long way since then. While gravity bombs dropped from aircraft are still around in some arsenals, missiles are now the preferred way to go. They're faster, they're less vulnerable, and they have a much longer range.
I've heard of ICBMs. Are those the main way nuclear weapons are delivered these days?
ICBMs, intercontinental ballistic missiles, are definitely a major part of nuclear arsenals. They can travel thousands of miles, delivering nuclear payloads basically anywhere in the world. Then you've got submarine-launched ballistic missiles, or SLBMs, launched from submarines that stay hidden deep underwater, making them very hard to detect and intercept. And then you can't forget MIRVs, multiple independently targetable re-entry vehicles.
I don't think I've heard of those before. What makes those unique?
Well, imagine one missile carrying multiple warheads, and each one can hit a different target. That makes it really difficult to defend against, like trying to stop a shotgun blast of nuclear destruction. And then you have tactical nuclear weapons. They have even more delivery options: artillery shells, landmines, depth charges, even nuclear torpedoes.
Wow, so much to think about. It really brings us to another complicated aspect of this whole thing, nuclear strategy. It's not just about building them, it's also about how they're used. Or, I guess, how the threat of using them affects things globally.
Yeah, that's right. Nuclear strategy is all about how you use the existence of these weapons to achieve your goals, and particularly to prevent war. This idea of nuclear deterrence is really central to that.
Our research really emphasizes nuclear deterrence as the most important part of nuclear strategy. Can you explain what that means?
Nuclear deterrence is the idea that you can prevent an attack by threatening to retaliate with devastating force. You make the cost of attacking so high that it's just not worth it for the other side. The goal is to create a situation where both sides are so afraid of a nuclear war that they won't even consider starting one.
So it's kind of a balance of terror that aims to maintain peace.
In a way, yeah, it's a delicate balance, and it has its critics. There's always the risk of miscalculation, accidents, or even just intentional escalation. But the theory is that the consequences of a nuclear war are so catastrophic that they act as a very powerful deterrent.
The sources mention second strike capability and first strike status. What's the difference and why do those matter?
Second strike capability means you can survive a nuclear attack and still be able to retaliate. It's seen as a way to maintain stability because neither side has a reason to launch a surprise attack. First strike status, on the other hand, means you can wipe out the enemy's nuclear forces before they can retaliate. That's a much more destabilizing idea because it makes you want to strike first, thinking you can win a nuclear war.
So one is about making sure you can retaliate, and the other is about disarming your opponent preemptively. It sounds like a very dangerous game of chess.
That's a good way to put it. And it's why understanding these concepts is so important. Like during the Cold War, strategists used game theory to model different scenarios, to try and figure out how to create stable deterrents. They were basically looking for strategies to minimize the risk of an accidental or intentional nuclear war.
Makes sense. With the threat of ICBMs and SLBMs and all that, I'm not surprised countries have invested so much in missile defense systems.
Oh yeah, missile defense is all about trying to shoot down those incoming missiles. But it's so difficult and expensive. And there's always the risk that it won't work. And then you've got civil defense measures, like early warning systems and fallout shelters. But those offer very limited protection if there's a full-scale nuclear attack.
It's a pretty stark reminder of just how destructive we're talking about here. It leads us to, I think, the heart of the debate about nuclear weapons. What are the arguments for and against them, and why is this such an important debate to have?
Well, one of the main arguments in favor of these weapons is that they actually prevent large-scale war. The logic is that the threat of mutually assured destruction, or MAD, makes it too risky for anyone to start a nuclear war. Some people even say that more countries getting these weapons could actually make the world more stable by creating a more complicated web of deterrence.
Really? That seems kind of counterintuitive, doesn't it? Wouldn't more countries with these weapons make things more dangerous?
It's definitely complicated, and there are good arguments on both sides. The people who support more countries having them argue that it creates a stalemate where everyone is afraid to attack. But the people against it say that it increases the chances of accidents, or miscalculations, or even terrorism. They say that would make the world a lot less safe.
That makes sense. What about non-state actors, like terrorist groups? What happens if a group like that gets a nuclear weapon? How do these deterrence strategies work then?
That's one of the biggest challenges with nuclear strategy, because it assumes that everyone is rational and will act in their own self-interest to avoid being destroyed. But what happens when you're dealing with someone who's willing to die for their cause? Even if it means causing a nuclear disaster, those strategies may not work in those situations.
So how do we deal with that threat?
Some experts talk about something called expanded deterrence, which focuses on not just the terrorists themselves, but also the countries that might be helping them get nuclear materials or technology. The idea is that if you threaten to retaliate against those countries, you make it less likely that they'll help these groups.
It's about holding the people who enable them accountable for their actions. Seems like it's a pretty complicated problem that needs a multifaceted solution.
It is. There's also a growing focus on nuclear forensics, which is the science of tracing those materials back to their source. So if an attack happens, you can figure out where the material came from and hold them responsible.
It's like a global detective story, but with unbelievably high stakes. And it highlights how important international cooperation is in tracking this stuff and making sure it doesn't fall into the wrong hands. We've covered a lot in this first part, from the science to the strategies, the different types, the ongoing debates. It's a lot to take in. So I think it's a good place to pause and think about what we've learned. We'll be back in the next part to talk more about accidents, testing, and the effects of these weapons on people.
It's important to understand the whole picture, the technical aspects, and the human consequences. This is definitely a conversation that needs to continue, because the decisions we make today about these weapons will have a huge impact on the future.
Welcome back to our deep dive into nuclear weapons. In part one, we talked about the science behind these weapons, the different types, and the strategies for using them. Now we're going to get into some heavier stuff, the accidents, the testing, and what these weapons do to people.
It's definitely important to understand the potential consequences. It really helps us understand the seriousness of the issue. We talk a lot about deterrence, but it's also crucial to recognize the risks and the very real impact these weapons have had and could have on humanity.
You're absolutely right. We left off talking about broken arrows, those accidents with nuclear weapons that don't risk starting a war. Our research says there have been a lot more of those than people realize, which just shows how dangerous these things are.
Oh, absolutely. Experts think there were as many as 50 nuclear weapons lost just during the Cold War, and some of them were really close calls. Like in 1957, a B-36 bomber was carrying a Mark 17 hydrogen bomb, one of the most powerful bombs ever built, and it accidentally dropped it near Albuquerque, New Mexico. Thankfully, the nuclear capsule didn't detonate, but the conventional explosives in the bomb did. It created a crater 25 feet wide. It just shows how easily things can go wrong.
That's pretty scary to think about. A near miss with a weapon that powerful. And the research mentions another incident in 1961, where a B-52 carrying two nuclear bombs broke apart in midair over North Carolina.
Yeah, that one was terrifying. One of the bombs actually went through a few of the arming steps before it failed to detonate. It really shows how complex these weapons are and how they could potentially fail catastrophically, even with all the safety mechanisms they have.
It's a reminder that we're relying on technology and people not making mistakes to prevent huge disasters. And then there's the whole issue of nuclear testing and the fallout that comes with it. We talked about how big explosions can send radioactive debris into the atmosphere, but what does that actually do to people and the environment?
Well, the impact of nuclear testing is significant, and it lasts a really long time. One of the first big incidents that made people aware of this was the Castle Bravo test. It was a hydrogen bomb test in 1954 in the Pacific. And this Japanese fishing boat, the Lucky Dragon, was fishing about 80 miles away from the test site. And they got caught in the fallout. The crew got a significant dose of radiation, and one of the fishermen died a few months later.
Our research indicates that this incident really sparked concerns about fallout, not just for people nearby, but also far away.
Absolutely. The Lucky Dragon incident showed that fallout doesn't respect borders, and it can have consequences that reach far and wide. Exposure to radiation can lead to serious health issues, like cancer, birth defects, and other genetic damage. The long-term effects can be devastating, both for individuals and for future generations.
So what have we learned from studying the long-term effects of these tests? Have there been any definitive conclusions?
There have been a lot of studies trying to figure out the damage caused by these tests. For example, the Centers for Disease Control and Prevention did a study, and they estimated that fallout from atmospheric nuclear tests would likely lead to about 11,000 extra cancer deaths. And that's just among people who were alive during the testing period in the U.S. The global impact is much harder to figure out, but it's definitely significant.
Those numbers are pretty alarming. It seems like the legacy of nuclear testing is still affecting us today. And this brings us to how the public reacted to these tests and the growing awareness of the dangers they posed. Our sources mention the rise of peace movements like Ban the Bomb and the Aldermaston marches in the UK. They seem to have been really important in raising awareness and pushing for change.
Those movements were definitely key in bringing the issue to the public's attention. They organized protests, marches, educational campaigns, they mobilized public opinion, and they put pressure on governments to do something about it. Their efforts played a big role in shaping international policy on nuclear weapons.
And that pressure led to the Partial Test Ban Treaty in 1963, right?
It did. That treaty banned atmospheric nuclear tests, which really reduced the amount of fallout being released. It was a huge step forward. But it's important to remember that testing continued underground.
And then in 1996, the Comprehensive Nuclear Test Ban Treaty was adopted to try and ban all nuclear explosions no matter where they happen.
Right. That treaty was a big win in trying to limit the spread and testing of these weapons. But it hasn't actually gone into effect yet. It needs to be ratified by all the countries that have nuclear capabilities, which is still a challenge in the world of international diplomacy.
It seems like we've made progress, but getting rid of these weapons is still a long and difficult process. But before we get into that, let's talk about what happens when one of these weapons explodes. What are the immediate and long-term effects?
Well, the immediate effects are well documented. And they're devastating. You have a massive fireball that's hotter than the sun, a shockwave that can flatten buildings for miles, and intense heat radiation that can cause severe burns even from far away. And then there's the radiation from the explosion itself, which contaminates the environment and poses serious health risks for years to come.
The research paints a pretty horrifying picture of the destruction and suffering. And we often hear about nuclear winter as a potential long-term consequence of a big nuclear war.
Yeah, the concept of nuclear winter is really scary. The idea is that the smoke and dust from multiple nuclear explosions
Mm.
could block out the sun for a long time, causing global temperatures to plummet, and basically triggering a catastrophic climate change event. Like imagine a global ice age, with crops failing, mass extinctions, maybe even the end of human civilization as we know it. It shows just how dangerous these weapons are.
It's a terrifying thought, and it's important to remember the people who would suffer, not just from the immediate casualties, but also the long-term health problems for survivors. Our research mentions the horrible things that happened to people who survived the Hiroshima bombing.
The survivors of Hiroshima and Nagasaki face so many immediate and long-term health issues. Severe burns, radiation sickness, higher risk of cancers, psychological trauma, just terrible consequences. And many of those effects are still being felt today, decades later, not just by the survivors, but also by their children and grandchildren.
It's a tragic reminder that we need to prevent these events from ever happening again. Their stories show the true cost of nuclear war, a cost that goes far beyond the immediate blast and echoes through generations. And it brings us to a really important question. How do we move forward? How do we address the threat of these weapons, and what role should they play in the future? So we've spent the last two parts of this deep dive exploring the science, the history, and the devastating consequences of nuclear weapons. It's been, well, pretty heavy stuff, to say the least. But now I think we got to tackle the big question. Where do we go from here? What does the future hold for these incredibly powerful weapons?
That's the question that's been on everyone's minds. Policymakers, scientists, activists, everyone for decades, really. And there are no easy answers. But I think a good place to start is recognizing that there are different views on what role nuclear weapons should even play in the world.
Yeah, and our research definitely shows that. Some people argue that despite how destructive these weapons are, they've actually helped to keep things relatively stable globally. How does that argument work?
Well, it's this idea of peace through deterrence. The thinking is that the fear of mutually assured destruction, MAD, has actually prevented those big powers from fighting each other directly. They say that because the consequences could be so catastrophic, it's forced countries to find other ways to solve their problems. Basically, it makes war unthinkable.
So it's like, I don't know, a really high-stakes game of chicken where everyone knows if they swerve, it's all over.
Yeah, I guess you could say that. It's a simplified analogy, but it kind of gets the point across. And some people who believe this, they even say that if more countries got nuclear weapons, it could actually make the world even more stable.
Wow, that's a pretty controversial take. Wouldn't more countries having these weapons make things more dangerous? More risk of accidents, mistakes, or someone actually using them?
Those are all valid concerns. The counterargument is that if more countries have them, it creates this complicated web of deterrence where no one would risk an attack. But people who disagree with that idea say it's too unstable, it assumes everyone will be rational and act in their own best interest. And, well, history has shown us that that's not always how things go.
Right. And then there's the whole issue of non-state actors, like terrorist groups. Does this deterrence idea even work with groups that might not follow the same logic as a country?
That's a really tough question. It's one of the biggest challenges to the whole deterrence idea. How do you deter someone who's driven by ideology and maybe willing to sacrifice themselves for their cause, even if it means a nuclear disaster? Those traditional deterrence strategies, threatening retaliation and self-preservation, they might not be very effective in those situations.
So if that doesn't work, what are the alternatives? How do we deal with that kind of threat?
Well, there are a few approaches people are looking at. One is what's called expanded deterrence. That focuses on not just deterring the terrorist groups directly, but also targeting any countries that might be helping them get nuclear materials or technology. It's making it crystal clear that any country involved in nuclear terrorism will face serious consequences. Basically, making it too risky to even think about supporting those groups.
So holding the enablers accountable, making it too dangerous for any country to help terrorist groups get nuclear weapons.
Exactly. You create all these reasons not to do it. Show the world that the international community won't tolerate any kind of state-sponsored nuclear terrorism. And on top of expanded deterrence, there's also a growing focus on nuclear forensics, like we talked about before.
Yeah.
Tracing those materials back to where they came from. The idea is to quickly figure out the origin of any nuclear material used in an attack so you can respond effectively and hold the right people accountable.
Like a global detective game with incredibly high stakes. It takes international cooperation and the latest scientific techniques to keep track of this stuff and make sure it doesn't get into the wrong hands.
Yeah, exactly. And that leads to the bigger question, what would a world without nuclear weapons even look like? And what are we doing to get there? It's complicated, there's no easy fix, but people are working on it. Reducing stockpiles, strengthening those non-proliferation treaties, developing new technologies to detect and intercept these weapons.
Our research points to some key initiatives, like the new START treaty between the US and Russia to reduce the number of deployed warheads. Then there's the International Atomic Energy Agency. They're monitoring nuclear activities and promoting the peaceful uses of that technology. And we're seeing more investment in technologies to try and catch nuclear materials before they can be trafficked or get into the wrong hands.
It's all good, but it's still really challenging. You've got geopolitical tensions, countries not trusting each other, and all sorts of technological hurdles, and people still debate about it. Some think nuclear weapons are a necessary evil, that they've kept the peace for a long time. Others believe they're a huge threat that needs to be eliminated completely.
It's a debate that's worth paying attention to, and I think it's important for all of us as informed citizens to participate in that. We've covered a lot in this deep dive, from how these weapons work to the risks they pose and the challenges in dealing with them. But we've also seen that there are people and organizations dedicated to minimizing those risks and working towards a safer world.
Absolutely. The choices we make, both as individuals and as a global community, will determine the future of these weapons. We need to keep learning, having these discussions, and supporting policies that promote peace and security for everyone.
Well said. We hope this deep dive has given you a better understanding of this incredibly important issue and that you'll keep exploring it, asking questions, and having those productive conversations. Thanks for joining us.